Hi, and welcome to today's video. Today is the part 4 in our series of videos that looks at tool design, more specifically jigs and fixtures. And well, today we're going to be producing some jigs and maybe a fixture. We're going to need 2 jigs because we have 3 holes to produce in this blank part. And you may recall we produced this part on the shaper and on the mill and on the bandsaw. So we're going to reacquaint ourselves with this part on the whiteboard in a few seconds. But what we're going to be looking at is producing jigs and fixtures in a very basic, simple way. And we're going to be producing what I would call a modified plate jig for the 2 holes through the primary surface, and we're going to be using a poor man's angle plate jig for the hole that heads through the tertiary surface. So let's head over to the whiteboard and take a look at those dimensions. So let's start with our surfaces. We have a pair of primary surfaces, the largest surfaces. We have a pair of secondary surfaces, the second largest, and tertiary, the third largest pair of surfaces. We also have a pair of angular surfaces. The first one here, well, it already exists on our blank part. And the second one, well, this one doesn't exist yet, and we'll be producing a milling fixture for that one. We also have 3 through holes, 2 that are through the primary surfaces and 1 that passes through the tertiary surfaces. A little side note here, that third hole, the one that's perpendicular to the tertiary surfaces, well, it starts perpendicular to a surface, a flat surface, but it ends in an angular surface. It crosses or it passes through that second angular surface, and that's one of the reasons why we haven't produced that angular surface yet, because drilling through a surface at an angle is a big problem. Not an insurmountable problem, but a big problem. Why make things more complex than they need to be? There are ways to drill properly through an angular surface, but we'll have to look at that in another video. So we'll be drilling that hole first, and we'll milling the angular surface after. This hole through an angular surface is a perfect example of why it's so important to plan properly our sequence of operation when machining a part. If we perform some operations before others, we can really machine ourselves into a corner. So if you haven't already done it and you're so inclined, take a while and go and watch the series of videos that I produced on planning a proper sequence of operations. You'll find links to these videos at the end of this video, as well as in this video's description. So here's the part that we're going to be drilling, and here's the part that I've chosen to use to produce my plate jig. Now, this is going to fit on or in this, we'll see in a few minutes, and I'm going to want to position it this way, with this lopped off corner up here, because we're going to be using that as a foolproofing feature. We'll see what that means a little later. So what I don't want to do here is waste an awful lot of time measuring things. Whenever I can avoid it, I avoid it. So I want to leave myself some room here, because this end here is going to be a reference end. So I'm going to just put that down there, just like this. Okay, and that'll hold my part in place. And I can lay it one line. Then I can come up to the top. I want to leave a little bit on that side as well. And I can again, sorry, I'm at an odd angle because I don't want to block the camera angle here. So it looks a little more laborious than it should be. And there, I'm going to draw a line there. So I have my 2 lines on that side. And what about this side? Well, this side, so 1, 2, 3 lines there. Now, as far as the sides go, I want to leave a little bit as well. So that was how my part was oriented, right like that. Now, we've calculated that the leftover on each side should be 0.325. So I've set my calipers at 0.325, and I'm just going to hold that there, come over and check it on this side. So that is where I want it. And remember, just like I did with the other ends, I don't have to go out of my way to make this actually very, very accurate. So what I'm going to do here is, I'm going to hold that, I'm going to come up there, and I'm going to come up there. So there's my 4 lines for my part. There's my overall length line there as well. Now, we can head over now to the bandsaw and cut this off in a way that leaves that line there, so I can just see that line. So let's head over to the bandsaw. Here's the part set up in the vise. Now notice that I'm holding the part just really in the tip of the vise, and I'm worried that this jaw is going to cock sideways. So to prevent that, I'm using a spacer block in the back the same width as the one that I'm holding in the front. It'll hold much better that way. It's good to note here that my spacer block barely engages in the vise. I don't want the block to be right into the center of the vise and stop the vise from holding this part properly. So good engagement here, very short engagement here on the spacer. So let's take a cut. And don't forget, for safety's sake, when we cut on the bandsaw, it produces quite a sharp and dangerous burr there. So when you're done cutting, we'll remove that burr. There. So we have our part, and well, it's not sharp to cut my fingers on. So here's my part, and well, this is the surface that I've just cut. It is pretty good actually, but just to ensure that I can really hold it in the vise safely and tightly, well, I'm going to come and flatten that off. Now, I could do it in the mill, but I'm going to be using the shaper here, mainly because I don't get to use it very often. And well, this is a good excuse to do so. Now, I'm going to be pocket milling, well, this pocket here. And I want square corners, but I'm not going to get square corners if I pocket with an end mill. And that's what I'm going to do. So in order to get corners that don't interfere with my part when I insert it, I'm going to relieve the corners by drilling a 1/4 inch hole in each corner. And well, this doesn't have to be particularly accurate, so I'm just going to prick punch, center punch, and drill the holes. So my center punch marks aren't quite wide enough to accept the chisel edge on the end of a 1/4 inch drill. And that's no problem. I'm going to use this center drill not to produce a large center drill, just really to use the V-tip here on this very rigid, short, stubby drill to come and make these marks a little bigger. That's all I'm doing here. So this is called spotting the holes, and then I'll put my 1/4 inch drill in and drill through. Now we can go deburr or countersink these holes just for safety, and then we're going to head over to the mill to pocket this out. Okay, the mill is set up, my vise is aligned. Don't worry if you haven't seen it, because we do have videos that cover all this stuff, so I'm not going to redo it here. The vise is aligned, I'm ready to go. Now, I have a smallish end mill in there. What's smallish? Well, it's small, but it's not the smallest that I'm going to need. It's a little larger actually than what I need. I'm going to finish here with a 1/4 inch or slightly smaller end mill, so that I can really work my way into the 4 corners without leaving any edges or radii on the corners. I want the block to sit in there properly. But that's going to take a long time to mill, so I'm using a little bit of a larger 2-flute cutter that I found in the bottom of one of my toolboxes. And actually it's a cutter that I had sharpened when I was an apprentice. That's many, many years ago, 40 something anyways, and I guess we'll see if I did a good job. We'll see how it's cutting. Now, my plate here is 3/4 of an inch thick. I want to have enough depth on this hole or this pocket that I'm milling to be able to really get some screws as work holding devices. So probably a 1032 or something like that. So 3/8 depth, that's what I'm going to want to cut at. I won't be cutting it in one shot. This machine isn't rigid enough for that kind of thing. And once I'm down and pretty well all opened up, I'll pull out, change the end mill for a smaller end mill, and then do a finishing pass around the edges just to finish things up nicely. So I'm going to go get my safety glasses and we can start cutting. So here's the jig body, and you can see the pocket that we produced. Here's our part that we want to drill. It's quite loose in there, and that's okay. I want it to be loose. I don't want to have to struggle when I load and unload this tool. There's no reason for it to be snug or even slightly close to being snug. Loose is good enough. I figure somewhere around the 25 to 50 thousandths of an inch is fine with that. So that's done. We still have some work to do, but it won't be done today because I've hit about the limit of my attention span, and well, I think it's time to call it a day. So until we meet again in part 5 of this series of videos that's all about jigs and fixtures, we'll have fun. Be safe. It's so important. And happy machining.